Hello and welcome to this case study. So in this case study, we are going to forecast sales of retail giant Walmart. So in this project, we are provided with data of 45 Walmart stores located in different regions. Each store contains many departments and you have to predict department-wise sales for each store. And Walmart also runs several promotional events throughout the year, which are on holidays like Christmas and Thanksgiving, Labor Day. So the week including these holidays are weighted 5 times higher in the evaluation than non-holiday weeks. Suppose the first week of December, it's a non-holiday week, so that sale will be different than the last week of December because it has Christmas and New Year Eve. So the sales will be different. Walmart is one of the biggest retail store in the world. Walmart helps people around the world to save money and live better anytime and anywhere. It has retail store, it has online stores, and people can purchase their products through mobile. And each week, over 265 million customers and members visit approximately 11,500 stores in 27 countries and also on their e-commerce website. So by the year 2020, the revenue of Walmart is $524 billion. And Walmart has over 2.2 million employees worldwide. So the basic idea of analyzing the Walmart forecasting dataset is to get a fair idea about factors affecting the sales of Walmart store. So in this case study, we have datasets like features.csv, stores.csv, test.csv and train.csv. So we have total of 4 datasets. Let's open train.csv. So we have different sales value in train.csv. We have the date and we have is holiday, whether there was a holiday on that date. So which is this week. And here is the store name and department name. So in that way we have a data set for many stores and of many weeks. Similarly, we have store.csv where we have information about different stores. Here the store is one type of A and size is 1,51,315. And then we have features.csv. Here we have date, temperature, fuel price and marked down from 1 to 5. And then we have CPI, unemployment, is holiday. So we have information which is required to build the model. So I'll share the link to this folder. Here you can download the notebook and as well as dataset, and you can upload it in your drive and you can start working on it. Let's start our case study. So our main problem statement is to predict the Walmart sales based on different parameters. So our main problem statement is to predict the Walmart sales based on different parameters. So let's check the data set. So let's check the information about all the columns which are present in these files. So first we have stores.csv file. So which is this one. So in this file, we have information about 45 stores indicating type and size of the store. So this is the type and this is the size of the store. And then we have train.csv which covers the data from 2010 to 2012 of 11th month. And then we have train.csv which covers the information from this date to this date. So in that file we have store number and we have department number and we have the week number, the date of that week, and we have weekly sales for that given store and whether the week is specially holiday week or not. And then we have test.csv file. Test.csv file also have same information And then we have features.csv file. In features, we have store number, week, temperature in that region, and cost of fuel in that region. And we have markdown 1 to 5, which means the markdown is the data only available from so delete that markdown 1 to 5. And then we have markdown 1 to 5. So markdown is anonymous data related to promotional events that Walmart is running. So in many weeks there will be a few promotional events, few promotions for that festival leaves. And then we have CPI, consumer price index. And then we have unemployment rate. And then we have information about is holiday. So it is true or false whether the week is specially holiday week or not. So if it is a holiday week, then it will be true. If not, it will be false. And for your convenience, we have 4 holidays that will fall in this weeks of the data set. We have Super Bowl, which falls in February, and we have Labor Day, which falls in September, and we have Thanksgiving week, which falls in November, and we have Christmas week, which falls in December. So we have usually promotional events during these weeks. And then we have business objective. So the main objective is misclassification can be very high. So the cost of misclassification can be very high because if we don't forecast sales properly, then there will be so much loss because company need to spend on employees, company to spend on decoration, and there are so many things company to keep offers. So if we are predicting some sales in particular week, then company will plan it accordingly. So they will plan number of employees that need to be present in that week and what are the arrangements that need to be done. So we cannot misclassify any information. So let's start the project now. So first thing is we are importing all the important libraries. So we are importing NumPy, Pandas, and we are importing Matplotlib and Seaborn and Plotly for visualization. And then we are importing sklearn methods and library. And we are importing regression, lasso regression, mean squared error, R squared error, grid search CV, random search CV, and finally we are importing warnings to ignore the warnings. So first to import the data set, we need to mount our Google Drive. So using this code, we will mount our Google Drive. So press Shift Enter to run the cell. So now we need to click on this link and so that we'll get authorization code and we'll paste it here. So I'll click on that link and I'll select my Gmail account. And then I'll give permission to the Google Drive. And then finally I'll copy this authorization code and I'll paste it here. Let's run the cell. Now we have successfully mounted our Google Drive. So now after mounting our Google Drive, first thing we are doing is reading the CSV file. So now we have mounted our Google Drive. Now we will read our CSV file. So to read our CSV file, we are using pandas.read_CSV. And here we are giving the path. So we have 4 files: train file, features file, store file, and test file. So we are storing train file in train_df data frame. So here, if you have different path, if you have downloaded these files and saved it in different folder, so you can give the different path. So but here, as I have saved it in this path, I will paste the path here. So in order to copy this path, you can click on Drive. You can go to Drive, My Drive, Machine Learning Projects, Regression, and then I'll go to Walmart. And then I can copy the path here, train.csv. So I'll click on Copy Path and I'll paste it here. I'll remove this and I'll paste Ctrl V. So this is my path. So similarly for all our data sets, I've pasted their path. Now I'm going to run this cell. I'll press Shift Enter to run this cell. Okay, so we have not imported all the important libraries. So I'll just run this cell. So now we can import the data set. So now using dot head method, we can check the information about top 5 rows. Let's run this cell. So in trend underscore df, we have store, department, and we have date, and we have weekly sales, and whether we have holiday or not. Let's check all the column names in trend df. So we have all these column names. Now let's check the shape of our trend data frame. So we have 4,21,000 data points, which is 4,21,570 data points, and these many rows, and we have 5 columns. Let's check the information about all these columns, whether they are string or number. So here we have store in integer format and department in integer format, date is in object format, and is holiday is boolean value, and weekly sales is float. So we have these 2 columns which are not in numbers format. Now let's check the more information about these columns. Let's check their mean, standard deviation, and average. So here we can see that we have 4,21,570 values for all these columns, and the mean store value is 22, and the department is 44, and the weekly sales are mean weekly sales are 15,981. So let's take these values in dollars. So then we have standard deviation and minimum. Minimum is minus 4,988 sales, which means this is in negative. It means the store is in loss. And we have maximum sale of 6,93,000 or $693,000. So this is the maximum sale, and the 75th percentile comes under 20,000. So 75% stores have $20,000 weekly sales, and the standard deviation is $22,711. Now let's check whether we have any null values or not. Let's run this cell. So here we're not able to see any null values. Let's sum the null values. So we have 0 null values. So we have a good data set. Here we have 4,21,000 data points, and we don't have a single null value. That's very good. Now let's check the top 5 rows in features data frame. So in features we have date, and we have temperature, and we have fuel price, and we have markdown, markdown 2, markdown 3, 4, 5. So you can see here we don't have any promotional events, and we have CPI, which is consumer per index, and then we have unemployment, and then we have is holiday, whether it's any holiday or not. So here 2010 second month and 12th date, that week has holiday. So maybe Valentine's Day, because we have Valentine's Day on 14th February. So in the similar way, we have information about all the features which are required to predict the sales. Now let's check all the column names. So we have all these column names. The reason we see df.columns is because we cannot see all the column names in df.head because of the dataset size. So we will check it using df.columns. Now let's check this shape of all the features. So here we have 8,190 data points, which are rows, and we have 12 columns. So the reason we have the size of this data frame is small is because it contains information related to store, department, and regional activities. So we have very small data set for features, but our main data set is train, which has more than 4 lakh data points. Now let's check the information about all the columns which are available in features data frame. So these are in terms of integer, float format, and the store is in integer format in 64, and date is in object format, which is string, and each holiday is in boolean format. Now let's check the mean, median, average of all the data points. So here we have total count of 8190, and the mean temperature is 59, and the standard deviation is 18, and the minimum temperature is -7. It means it's very cold region, and the maximum temperature is 101. I mean, it's very hot. And then 75 percentile of temperature comes under 73. And then we have fuel price. We have minimum fuel as $2.4, and we have 75th percentile as $3.7, and maximum fuel price in that region is $4.4. And we have markdown 1, markdown 2, and we have markdown 3. And then we have CPI and unemployment rate. Let's check whether we have any null values in this data set. So let's check for null values. So see, here we can see there are so many null values. Here we have true, true, true. So these columns have many null values. Let's sum the total null values. So in markdown 1 we have 4158 null values. In markdown 2 we have 5269 null values. And in unemployment we have 585 null values, and in CPI we have 585 null values. So these are all the null values. Now let's check the information about stores data frame. So here we have store, type, and size, and we have for the store one and type A, the size is 1,51,315. And then we have column names. Let's check the shape. So we have 45 rows and 3 columns, because this data frame contains information about 45 stores, indicating the type of the store and the size of the store. Let's check the information. So this is in integer format, and the type is in object format, and size is in integer format. Let's check the mean and average. So here store mean is 23, size is the mean size is 1,30,000, and the maximum size is 2,19,000. Let's check the null values in store. So I'm not able to find the null values. Now let's check the sum of null values. So we can see that we don't have any null values in the store. So now let's proceed further. Now let's visualize the type of the store along with their percentage. So here we are taking labels and values. So labels are type of the store, and here we are taking value count index, which is the serial number, and then we have value count dot values, which means we are taking values, and we are creating a pie chart using Go method of Plotly library. Plotly is one of the data visualization library which is similar to Seaborn. Okay, we'll press Shift Enter to run the cell. So here we can see that type A has 48.9% of stores, and type B has 37.8% of stores, and then we have type C has 13.3% of stores. So here we can see that type A has a maximum number of stores. Since we have so many same features in features data frame and also in stores data frame, we can merge them together. So now let's merge them together and we will create a new data frame with the name dataset. So here we are combining features data frame with stores data frame. So we are using dot merge method and we are using inner method on store. So this is the same column in both the data frame. Let's run this cell. So and we are visualizing top 5 rows also. So this is our new data frame, because in store data frame we had only few columns. Let's see that columns again. See, we had only store column, type column and a size column. Type column, size column, and using this store column, because that was the same column in these two sheets, so we have merged these two sheets on that column basis. Now let's check the column names in this new data set. So here we have these many columns: store, date, temperature, fuel price, markdown 1 to markdown 5, CPI, unemployment, whether there is any holiday or not, and there we have type, and then we have size. Let's check the information about this data set. So here we have one object, two object, and one boolean. So other are in numbers format. So we have date and holiday and type. So these columns are in object format, which is in string format, and the is holiday is in boolean format. Now let's check the more information about this newly created data frame. Let's check mean, median and average for this newly created data frame. So we will use describe method. So we have store, temperature, fuel price. So then so here we have size and unemployment. So here we have consumer price index. So we can say minimum consumer price index is 126 and maximum consumer price index is 228 and the mean is 172, and we have standard deviation of 39, and we have minimum fuel price as 2.4, and we have standard deviation as $0.43, and we have maximum fuel price as $4.4. Now let's check total type of stores along with their percentage in this modified data frame, I say. So in the same way we have 48.9 percentage of A type stores and 37.8% of B type stores, and we have 13.3% of C type stores. Now let's go to our test set. Till now we were checking our train data frame, and we have checked our stores data frame and features data frame, but we have not checked our test data frame. Let's also check that. So testdf.info. So here we have stores data, department data, date, and is holiday. So store and department are in integer format, and holiday is in boolean format, and the date is in object format. Now let's check top 10 departments in the train dataset along with their percentage. Let's close this. Let's proceed further. So here we are using train data frame, department column dot value counts, and here we are using index. So we are taking top 10 departments, and we are taking index value of them, and then we are taking dot values, the value in that column of department. So we are using go method of plotly library, and we are taking labels as label and values as this value. Let's run the cell. So here we are checking top 10 departments. So here we have 10% as department 1, 10% as department 10, and 10% as department 81, 10% as department 79, and then we have 10% as department 38, 10% as department 21. So everyone have equal departments. Let's check store type, like top 10 stores. So now it's a department. We are seeing top 10 departments. Let's check top 10 stores. So here also we are taking train data frame. We are selecting stores column. So there we are selecting department column. So let's run the cell. So here we have store 13 as 10%, it covers 10%, and we have store 10 which covers 10%, and we have store 4 which covers 10%, and store 1 which covers 9.8%. And similarly we have all the store details with total size. So now we have visualized the top 10 stores and top 10 departments. Now let's check how they work with holidays, like how holiday depends on these stores. Now let's visualize number of holidays. So here we are creating same pie chart, but here instead of stores we are selecting is holiday column, and here we are taking index, and then we are taking value. Index gives a serial number and values gives us exact value, whether it's true or false. Let's run the cell. So here we can see that we have 93% holiday as false, and we have 7% holidays as true. So we have nearly 4,21,000 data points, in which 93% times it is false, only 7% times we have true. So it means in 7% in 1 lakh it will be 7,000, and for 4,20,000 it will be more than like approx 30,000 are true, and the remaining all other data points are false. So this was about train data. So now let's visualize again our test data. So let's check the columns in our test data. So we have store, department, date, is holiday, and then let's check the mean and average. So we have store, department. So here we have standard store as standard deviation for store as 12.8, and we have minimum as 1, and we have department minimum as 1, and the maximum is 45, and we have maximum department is 99. So we have total 95 stores, and we have total 99 departments. Now let's check the information of our train data set again. Let's check the info. So here we can see that we have store, department, date, weekly sales, and is holiday. So here we have is holiday as boolean value, and we have date as object value. So these two are categorical data, and remaining other are in numbers format, and date is in string format. So we need to convert that into a numerical format or date time format. So we will convert all the dates in all our columns in test, train, and also in our features column. So let's take from date time, import date time. So we have merged our features and stores data frame as data set. So it also has a date column. So we will convert pt dot to underscore date time data set date. So we are converting date column from this data frame into date time format, and we are storing it in same column. So in the same way we are converting our string format date and time to date and time format. So in train df and test df, so it will convert into date. So now we need week and also year. So we will run this cell first. First we will check the information in our data set. So let's check train df again. So here it's date. Now let's check the info. So now the date is in datetime format. And now let's also check our dataset data frame. So in dataset data frame, we have converted date into date and time format. And we also need to create a week and year from this date. Let's also create those new columns. So we are creating dataset new column named as week, and we are using dataset dot date column dot dt dot week. So it will extract week from that column, and it will store it in a new column name as week. So here we don't have any new column with the name as week, so we will create a new column with the name week and year. Let's run the cell now. So we have created new column. Let's check that new columns. So here we have week and year. So this is date and this is week and year. So now we need to merge this data set with two data frames, with train data frame and also with test data frame. First, let's merge data set with train data frame, and we are creating a new data frame called train merge, which is equal to traindf dot merge dataset. This is traindf dataset, and this is dataset named as data frame. So which is the combination of features and stores data frame. So we are combining these two. We are merging these two using inner method and using store, date and is holiday columns. So we have these same columns in both of these data frame, and we are sorting all this value by store name and department and date. Let's run this cell. In the same way, let's also merge our test data frame. So we are merging test data frame with dataset data frame and creating a new data frame called as test merge. And it has a shape of 1,15,000. Let's create a scatter plot. First, we will create a function with the scatter, and we are giving train merge and column. And we will give a column name, particular column. And we will scatter the plot based on that column name which we provide. So now, as we have created this function, now let's use the function. So we are using this function scatter train merge, which is our data frame, and we are selecting the column as fuel price. First, we are creating a scatter plot with respect to fuel price, and then with respect to size and CPI, and also with respect to type, and with respect to is holiday, and unemployment, temperature, store and department. So we will create scatter plot based on all this information. First, let's run this function, and then we will implement this function to plot a scatter plot for all these columns. So we have plotted all these features. Let's check them. So our first plot is weekly sales versus fuel price. So here we can see the weekly sales with respect to fuel price. As the fuel price grows, I don't see much difference in weekly sales, but here in this region we can see that when the price is between $2.75 to $3.75, we have a good number of sales in I think various stores. Now let's see the graph between weekly sales and size of the store. So in this medium size stores, we have good number of sales, and also in large stores, we have good sales. And then we have CPI, Consumer Price Index. So here we can see that with the low CPI, we have a good number of sales. And then we have store type versus weekly sales. And we can see that for store type B, we have a good number of sales. And also for store A, and also let's check is holiday. When 1 means we have holiday, 1 means yes, 0 means no. So when we have holiday as true, which is 1, we have good number of sales. When we have holidays, people will not have much work, and they'll come for shopping. So that is when we have good number of sales. And then we have unemployment rate. So when unemployment rate is about 8 and 10, between 8 and 10, then we have good number of weekly sales. And let's check the temperature. So when the temperature is between 40 to 60, we have good number of sales. So if the temperature is very low, I mean it's very cold, people will not find it good to come out and go for shopping and to go for supermarket. And also when the temperature is very high, people will sit at home and turn on the AC, and they don't like to travel. So when we have optimal temperature between 40 to 60, this is when people find it comfortable to travel and to purchase groceries and purchase something from retail stores. And then we have store and weekly sales. It's normal, and then we have department. And for department like 70, we have good number of sales, and for department I think like 7, 8 and 10, we have good number of sales. Let's proceed further. Now let's check various other factors. Let's check average sales per year and find out if there is any holiday peak sale that were not considered by is holiday filled. Let's run the cell. So here we are finding average sales for the year 2010. So we are taking year 2010 and we are taking a weekly sales column and we are grouping it by week column. So here we can see that in the year 2010, in the last weeks, like after 40 week, we see that we have increase in sales. So here maybe after 50th week, we'll be having November, December. So in the last 3 months, we have good sales. Let's check the same for 2011. Let's run this cell. So we have data for 3 years, 2010, 11 and 13. Even for 2011, we have good number of sales for last 3 months approximately. Let's check for 2012. So in 2012, yeah, we have good sales for like all the weeks. Let's check the sales price, I mean weekly sales worth. So here we have sales worth $24,000 in that particular week. So here we have $18,000. So it starts with approximately $2,000 to $3,000. So the average here is approximately $16,000. So here also we have average of $16,000. But in the last 3 months we had a sale more than $25,000. But as we don't have data for last 3 months of 2012, we cannot see the sales for that particular weeks. Now let's plot these graphs combining so that we can compare 3 years. So 2001 line is blue color and 2011 is orange and 2012 is green. So 10, 11, 12. So comparing to all these months, we can see blue color line has more number of sales comparing to other lines. So it crossed this 26,000 limit, and it has also crossed 27,000 limit for all these weeks. So here after seeing these 3 years average sales per 3 years, and we came to know that 2010 performance is good comparing to all other years, like comparing to 2011 and 12. Now let's check sale department wise and store wise. Let's create a bar plot for weekly sales department wise. Let's run the cell. So we had good number of sales for this department. So we can click on it and we can zoom it. So we can see that we have good number of sales for this purple department. Here also we can see. Let's reconnect this again. And also in this department, we have good number of sales. So I think it touched $80,000 limit. So these two departments are performing very good. And also you can consider the all the departments which are performing above this $20,000 limit. So these are performing good. Now let's see sales per store. So I think as we've lost the connection with the Google Colab, we need to run all these cells again. So let's run these cells again. Let's check whether we have lost our mounting of Google Drive or not. Let's import all this. Let's connect our Google Drive again. Let's click on our Gmail ID. Now let's copy this authorization code and let's paste it here. And let's run the cell. So we are done till here, till that graph. So we will run all the cells till there. So we were checking average sales per store. So we will run everything till here. So it will start running all the cells in order. So it will take some time. Let's wait for it. Now let's check average sales per store. Let's run the cell now. So here it's average sales. It was here average sales per department and average sales per department. But here also we forget to write it as store. So let's make it as store. Let's run this again. So this is the average sales per store. Here we can see that this blue color, purple and maroon, green, blue, maroon. So these stores are performing really good in all these weeks. Now let's check the correlation between all these features. So here we are creating a heat map of correlation matrix. We are using sns.heatmap from Seaborn library, and we are keeping figure size as 20,15, and we are using train merge data frame dot correlation to compare all the features, all the columns of train merge data frame. Let's run the cell. So here we are going to predict our weekly sales column. So let's check which columns are mostly correlated. So with this we have good correlation with the size, and we have negative correlation with CPI and unemployment, and we have very much negative correlation with the fuel price. And then we don't have much correlation with this markdown 1, markdown 2 and 3, 4, 5. We don't have much correlation with this. And we also have good correlation with this unemployment negatively, and also with the year in negative way. So now let's do one thing. Let's remove this markdown 1, markdown 2 and markdown 5. Let's also remove this fuel prices because it's very negatively correlated. So let's remove all this from train data frame and also from test data frame. So now we are dropping column fuel price, markdown 1, markdown 2, markdown 3 till 5 from train merge data frame, from also test merge data frame. So we will remove these things from train merge data frame and test merge data frame. Let's run the cell. Let's check the head of our train merge data frame. So here these are our columns. Let's check the head of our test data frame. So we have date, is holiday, temperature, CPI, unemployment, size, week, year. So these are the columns which are available in test data frame. Now let's check number of unique values in our train data frames department. Let's check number of unique departments. So we have 81 departments. And let's check number of unique stores. So we have 45 unique stores. So let's check all the column names which are available in train merge. So in train merge we have store, department, size, week, year. Let's check the columns in test merge. So here also we have all the same departments except the weekly sales. In train merge we have weekly sales, but in test merge we don't have that weekly sales column. Now let's divide this data set into test and train set. So let's proceed further. So we are creating a new data frame named as X, and from train merge data frame we are selecting store, department, and we are selecting is holiday, and also we are selecting size, week and year. So the CPI, unemployment and the temperature, these are not that correlated, so we will remove this. And also we will remove the weekly sales because we don't need that in our X. So we will keep that in our Y. Based on this data, we will predict this weekly sales. Let's run this cell. Let's split these things X, Y. X is our features and Y is our label to training set and test set. So we will split 2 parts of X and 2 parts of Y. And we will split as 30% of test size and 70% of training size. So we are storing this in xtrain, xtest, ytrain and ytest. And we are doing this using train test split method of sklearn. Here we are giving input as x and y. Let's run the cell. So we have separated our x and y. Let's check our xtrain. So we have 2,95,000 entries in our xtrain. Now let's start building our model. First we are building ridge regression. So we are using GridSearch CV and we are giving parameters as alpha is equal to 0.001 and 0.001, 0.01, 0.1, 1, 10, 100, 1000, 10,000, 1 lakh. So these are the parameters. So GridSearch CV will create different models, and finally it will select one model that gives the best fit. And we are fitting this on xtrain, ytrain. And we have CV as 7 and the scoring method is negative mean absolute error. Let's run the cell. So our GridSearch CV has selected alpha is equal to 1 as best parameter. Let's predict the results. We will use predict method of ridge regressor to predict it on our xtrain and xtest. Let's run the cell again. So now let's check our training results. So during training we got root mean square error as 21,000 and our R squared error as 0.08. Let's check our test results. So here we got 21,811 as root mean squared error. So for root mean square error we are using mean squared error and we are doing square root. So for R squared error we got 0.084. Now let's create another model, lasso regression using GridSearch CV. So here also we are giving parameters from 0.001 to 1 lakh. So our GridSearch CV will create all the models and select which is the best model. So here we are using lasso regression and parameters are this parameter dictionary, and here we are using cross validation as 15 and the scoring method is same. And we are fitting this on xtrain and ytrain. Let's run the cell. So here our GridSearch CV has selected the best model. So as per this, we can see that alpha 1.0 is best parameter for alpha, and we have normalize is equal to false and maximum iteration 1000. So this is the best parameter. So we have hyper-tuned our model. Let's predict training and test results. Let's check our mean squared error for training. So here we got 21,975 as root mean squared error, 0.06 as R squared error. Let's check the same thing for test results. So for test we got 22,000 as root mean squared error, and we got 0.06 as R squared error. Let's do one thing. Now let's also implement decision tree and random forest. So many of the times random forest and decision tree gives you the best results. Let's use that. So now here first we are importing decision tree and we are creating a list with range of 3 to 30. And we are using GridSearch CV here. We are giving parameter grid as our parameters, hyper parameter tuning, and we have CV as 10. And then finally we will fit that to our xtrain and ytrain. Let's run the cell. So finally we got a model. So here we got a result, and here the alpha is 0.00. And here we have minimum sample if is 1 and minimum sample split is 2. and we have max depth is equal to none, comma max features is equal to none. So this is our best model. Let's check the results of this model. Let's predict it on xtrain and xtest. Let's run this cell. Let's check the results. Root mean square error and R squared error for train results and also for test set. So here we got 1998 as root mean square error and 0.99 as R squared error. It's comparatively very good than lasso regression and ridge regression. Let's check this for test set. For test set we got RMSE as 4889 and R squared error as 0.95. This is also good. Now I think random forest will give us the comparatively good accuracy than decision trees, because random forest has many decision trees. Let's check this. So here we are using random search CV because if we use grid search CV, it will take very long time, because in grid search CV it will create a grid and it will use all the models. But in random search CV, it will randomly select models and it will only use few models. And for hyperparameter tuning, here we are giving a number of estimators as 100 and 200 and minimum sample split as 2, 5, 10 and minimum sample leaf as 1, 2, 4 and the number of iterations are 3 only. So it need to select a good model within 3 iterations. Let's run the cell. So finally training is done. Our randomized search CV has selected our random forest model. So this is our model where we have minimum sample leaf nodes is none and maximum sample is none, and we have minimum sample leaf is equal to 1 out of this 1, 2, 3, 1, 2, 4, and we have minimum sample split as 2, number of estimator as 100. So this is our optimized model with hyperparameters. Let's check the results. Let's predict it. Let's use random forest regressor dot predict xtrain and predict xtest. Let's also check the root mean squared error and R squared error for training results as well as test results. So for training we got 2736 as root mean squared error and 0.9 at as R squared error. And let's see the test, and for test purpose, so in test results we got 3881 as root mean squared error and 0.97 as R squared error. So comparing to random forest, decision tree performed good. So for decision tree we got 4889 as root mean squared error and 0.95 as R squared error. So yeah, random forest is good. So here it has 4800. So let's see. Here we got 3800. So yeah, random forest is good comparing to decision tree model. So you can even try a few more other models. If you have more time, give more number of iterations, give more number of hyperparameters. So in this way you can build model to predict sales forecasting on this Walmart data. And if you have the data for any other supermarket related to Walmart or any retail chain, you can use the same method to forecast the sales. Yeah, that's it in this case study. See you again in the next case study. Thank you.